Until now, the decision was simple. One limitation. One method. Damage. You used acidizing. Low permeability. You used fracturing. This slide breaks that logic. Because in real wells, those conditions do not appear separately. They overlap. Now link that to what you see here. 3 ways to combine methods. Sequential, concurrent, integrated. These are not variations. They exist because the problem is no longer single. Now the statement in the middle explains why. Single methods fail. When multiple restrictions exist at the same time. Damage, low permeability, or different behavior across the reservoir. So the decision changes. Not which method to use, but how to combine them. Then the rule at the bottom defines the discipline. Hybrid treatment is not combining operations. It is optimized integration, which means each method is placed where it actually removes a restriction, and in the correct order. So this slide sets the shift. You are no longer selecting a treatment. You are designing interaction between treatments. The problem here is not complexity. It is overlap. Damage exists. Low permeability exists. And they do not act independently. That is the shift. In the previous lessons, you removed one restriction. Here, removing one leaves the other active. Now apply that to the first condition. Near-wellbore damage and low permeability. Acidizing removes the damage. But flow is still limited by the rock. Fracturing creates the pathway. But if damage remains, the fracture starts in a restricted zone. So each method alone fails. For a different reason. Now the second condition. Even if damage is removed completely, low permeability still controls flow. So the improvement does not scale. Now the third condition. Heterogeneous reservoir. Different intervals respond differently. One method improves part of the system and leaves the rest unchanged. Now the concept section. Hybrid is introduced here, not as combination, as separation of roles. One method targets one mechanism. Another method targets a different mechanism. Now connect them. The objective is not to apply more treatment. It is to match each restriction with the correct mechanism, and then align them in a way they do not interfere. So read this slide correctly. Hybrid is not used because the system is complex. It is used because the limitations act at the same time and cannot be solved independently. This slide is not listing options. Each block corresponds to a different physical problem. Start with the first one. Cleanout and matrix acidizing. This case is simple. Flow is blocked twice. First in the wellbore, then in the formation. If you apply acid first, it reacts with debris, not with the rock. So nothing changes. This block exists to enforce order, remove obstruction, then remove damage. Now second block. Matrix acidizing followed by fracturing. This is the most critical one. Damage and low permeability together. If you fracture first, the fracture starts in a damaged zone. That means the entry into the fracture is restricted. So even a good fracture underperforms. If you acidize only, you remove damage, but the rock still cannot flow. So neither method works alone. This block defines dependency. Acidizing prepares the formation. Fracturing creates the pathway. Now third block. Cleanout followed by fracturing. Different issue. Permeability is low. So fracturing is required. But access to the formation is not clean. If perforations are blocked, fracture initiation shifts. It may start in the wrong place. So geometry becomes uncontrolled. This block is about positioning, not permeability. Now step back. 3 strategies. 3 different failure modes. Obstruction. Damage. Incorrect fracture initiation. This slide is not about combining methods. It is about removing the condition that would make the next method fail. This slide separates 2 fundamentally different designs, not variations. Different physics. Start with sequential. 3 steps are shown. Cleanout. Acidizing. Fracturing. This is not a checklist. Each step exists because the next one depends on it. Cleanout first. If debris remains, everything injected afterward interacts with it, not with the formation. So nothing downstream works properly. Now acidizing. This removes near-wellbore restriction. Not for production yet. For preparation. Without this step, the fracture starts in a restricted zone. So the benefit of the fracture is reduced at the entry. Now fracturing. This is the only step that creates flow capacity, but it only delivers its full effect, because the previous two steps removed interference. So in sequence, first remove obstruction, then restore local flow, then extend into the reservoir. Each step enables the next. Now shift to the second part. Concurrent treatments. This is not sequencing. This is overlapping mechanisms. First case. Acid fracturing. One fluid. Two effects. Creates the fracture. And modifies the fracture surface at the same time. So conductivity is created without propant. Now second case. Fracturing with acid additives. Primary process is still fracturing. Acid is added to modify cleanup behavior, not to change the main mechanism. Now connect both parts. Sequential design removes barriers step by step. Concurrent design combines effects inside one operation. Now read this slide correctly. Sequential is about dependency. Concurrent is about interaction. Choosing between them is not preference. It depends on whether the problem requires preparation in stages, or combined action at the same time. This is where hybrid stops being optional. Start with the first condition. Damage and low permeability together. Now separate them. Damage restricts access near the well. Low permeability restricts flow in the reservoir. If you remove damage, flow still cannot sustain production. If you fracture directly, the entry into the fracture is already restricted. So both parts must be addressed. That makes hybrid necessary. Now second condition. Heterogeneous reservoir. Different zones behave differently. Same treatment applied everywhere. Creates uneven results. Some zones are overtreated. Others remain unchanged. So treatment must vary by zone. That is a hybrid by design. Now third condition. Complex near-wellbore region. Fill, damage, and low permeability exist together. Now nothing can work alone. Each method depends on the previous one. This is the full sequence case. Now move to the practical case. Carbonate reservoir. Moderate permeability. Damage exists. Fracturing is required. So the sequence is shown. Cleanout. Then acidizing. Then fracturing. Now focus on the failure case. Same well. Steps are skipped. Fracturing is applied directly. Now look at the consequence. Fracture initiates in damaged rock. Flow paths remain restricted. So the result is below expectation. Now connect both. Same reservoir. Same target. Only the sequence changes. One succeeds. One underperforms. So read this slide correctly. Hybrid is not required because the system is complex. It is required because each restriction blocks the next method, if it is not removed first. This slide has two parts. What hybrid achieves, and what can break it. Start with the advantages. First, multiple mechanisms are addressed. Each restriction is handled by a specific method, not partially improved, fully targeted. Now connect that. If 3 restrictions exist, single method treatment leaves 2 unresolved. Hybrid removes that gap. Second advantage. Each step improves the next. After cleanout, acid reaches formation. After acidizing, fracture starts in undamaged rock. So the effect is not additive. It is multiplied through sequence. Now third. Higher production than single methods. Not because more is injected. Because each restriction is removed at the correct stage. Now stop. Move to limitations. First, complexity. Each additional step introduces a failure point. Wrong execution in one step affects everything after it. Second, cost. You are adding stages, so the production increase must exceed that cost. Otherwise, the design is not justified. Now third, diagnosis. This is the critical one. If the restrictions are identified incorrectly, the sequence becomes wrong. And once sequence is wrong, even good execution cannot recover the result. Now go to the final statement. This is the control rule. Hybrid is optimized integration, not combining operations. Now connect everything. Advantages come from interaction between steps. Limitations come from incorrect interaction. So read this slide correctly. Hybrid does not guarantee better results. It amplifies the quality of your design. Good design gives higher performance. Bad design fails at a higher cost. This slide is not explaining hybrid. It is forcing decisions. Each scenario already defines the treatment. Start with the first one. Fill and damage. But permeability is adequate. That removes fracturing immediately. The reservoir can already flow. Only access is restricted. So the sequence is simple. Cleanout. Then acidizing. Nothing else is required. Now second scenario. Damage and low permeability. No fill. Now both restrictions are active. Acid removes damage. Fracturing creates flow. If you skip acidizing, the fracture starts in restricted rock. If you skip fracturing, flow remains limited. So this is a two-step dependency. Order matters. Now third scenario. Fill, damage, and low permeability. All three exist. Now every method depends on the previous one. First remove obstruction. Then remove damage. Then create flow. If any step is skipped, the next one loses effectiveness. Now last scenario. Carbonate with low permeability. Focus on the rock behavior. The formation reacts with acid. So fracture creation and conductivity can happen together. That leads to acid fracturing. Pre-flush prepares the system. Fracture and reaction occur simultaneously. Now step back. Each scenario answers one question. What restrictions are present? From that, the sequence is already defined. So read this slide correctly. You are not selecting methods anymore. You are mapping restrictions to sequence. And the sequence defines the treatment. This slide compresses the full logic. Do not treat the points separately. Each one confirms the framework. First point. Hybrid combines methods to address multiple limitations. This comes from slide 2. Restrictions do not act independently, so they cannot be treated independently. Now second. Sequential application. Cleanout. Acidizing. Then fracturing. This comes from slide 4. Each step prepares the system. Without sequence, interaction is lost. Now third. Acid within fracturing. This is the concurrent case. From slide 4 again. Different mechanisms working together in one stage. Now fourth. Sequencing is critical. This connects to slide 5. Skipping steps does not reduce effort. It reduces effectiveness. Now last point. Incorrect combination reduces performance. This connects to slide 6. Hybrid amplifies design quality. Right sequence improves results. Wrong sequence multiplies failure. Now step back. Each takeaway points to a previous decision. This slide is not adding information. It is locking consistency. Now close the lesson. In the previous 2 lessons, you selected a method. In this lesson, you structured how methods interact. That is the shift. Next lesson will move beyond treatment itself, to evaluating whether the design actually worked. This slide is the full system, not new information. A reference. One rule defines this lesson. Multiple restrictions require multiple mechanisms, and those mechanisms must be sequenced correctly. Cleanout, acidizing, fracturing only work when each step enables the next. If the sequence is correct, performance improves. If the sequence is wrong, results collapse. That is the takeaway. Hybrid is not combining methods. Hybrid is controlling interaction. Now you move forward. Next module focuses on design. Not what to choose, but how to execute it properly.